a tiddlywink is fired from the ground. Its height 8 cm is modeled by the equation h equals 24t minus 16t square, where t is the time in seconds. Sketch a graph to show the tiddlywink's flight. Find the maximum height that the tiddlywink reaches. So we look at the equation first because we have to do the graph. And if you look at the coefficient of t square, you see it's negative. So that would mean that the graph is n-shaped. So in my bad drawing, I would do something like this. Draw the axis later because I'm not sure about it now. So an n-shaped would be like this. The graph would be n-shaped. So let me write that down. So to do part A, the coefficient of t square is negative, and so the graph would be n-shaped. So next what we need to know is the intercepts. So the h-intercept when h is 0, then you would have 24t minus 16t square equals 0, which implies, so that would be, if you do 40, that would give you 6 minus 40 equals 0. Yeah, got that right. So that would mean, that implies the two solutions. So t equals 0, or 6 minus 40 equals 0, or 6 equals 40, meaning t equals 6 out of 4. That is 2 times 3 out of 2. So of course that is seconds. So t is 3 out of 2. So if that is 3 out of 2, then t is equal 0. So therefore we can say that if we are doing the graph, which we have to do, so therefore there's 1 0, and somewhere there is 3 out of 2, or if I can say that equals 1.5. So I would have 1.5 here, right? So that's bit is taken care of. So that's the next thing is what happens when t is 0. So when t is 0, so we can have, when t is 0, see h also equals 0. So at time 0, the height is 0. So therefore the graph extends on the time axis. So this is time, x-axis is always time, and this would be the height, and this is in centimeters, and so it would extend on the time axis, time is in second, from 0 to 1.5. I have to graph to show the flight. So of course the we have to find the maximum height. The height would be maximum in midpoint between 0 and 1.5. So we draw the graph first. I hope I can draw it well. It doesn't look great. So if this is the best graph I can draw, then this would be the maximum height. So that would be the path of the tiddlywink, and the maximum height, and this is the symmetry, the line of symmetry, and that would be when h is 0. Yeah, so that's done. So if I do the b part, so the maximum height is reached. Height is reached when time is 1.5 divided by 2, that is 0.75 second. So this would be 0.75. That is when the tiddlywink would reach the maximum height. So that's t is 0.75 second. Now when t is 0.75 seconds, we have to find what the height is. So the height would then be, you simply have to substitute the values, 24 times 0.75 minus 16 times 0.75 square, and what I get is 24 times 7.75 gives me 18 minus 16 times 0.75 square, that gives me 9. So that equals 9 centimeter, and this would be 9 centimeters. That's the maximum height the tiddlywink reaches. So that would be 9 centimeters. So I think we've done whatever the question asked us to do. Yes, that's right.